Hi, and welcome back to another video on weather radar. And in this video we're going to talk about volume coverage patterns, or VCPs. So volume coverage patterns are a result of the scan strategy of the radar. The way that the National Weather Service WSR-88D radar scans is that it makes a complete 360 degree scan of the atmosphere at a given elevation. And it usually starts at the lowest elevation angle. The lowest elevation angle for the radar is a half a degree above the horizon. And that half a degree we usually call the base reflectivity, or at least the reflectivity that comes back from that. Base meaning that it's the lowest elevation angle. And then after the radar goes through 360 degrees at that lowest elevation angle, it'll tilt up a number of degrees, and it will scan again 360 degrees at that elevation, that next highest elevation angle. And it'll keep going up in angles, a certain number of angles each time after a 360 degree scan. There are a number of elevation angles that the radar will scan through, depending upon the scan strategy, and that is called a radar volume. After it does, each elevation angle scans 360 degrees and goes to its highest elevation angle. That is called a radar volume, and you can think of it as almost a kind of a sphere around the radar. Of course, not going all the way up to pointing straight up, but just it looks like probably maybe a sphere with the top cut out, kind of like when you cut a pumpkin, you cut out the top. That's kind of what your radar volume would look like. So there are different scan strategies based upon what you want to look at, what the meteorologist wants to look at, what kind of weather there is. And we're going to break this down very generally into either clear air mode or precipitation mode. The National Weather Service radar, WSR-88Ds, operate in clear air mode when there is no rain observed in the radar volume. So this is the most sensitive mode of the radar. Starts at its lowest elevation angle, which is 0.5 degrees or a half degree above the horizon. The radar rotates very slowly because it is spending more time sampling. It's sending out more pulses, looking for more information. And each one of those pulses is longer duration, because the duration of the pulse means that there's more power going out with each pulse. And that's what you're looking for with clear air mode. You want to make sure that you send out a lot of power so you can get some power back from very small targets, very weak targets in the atmosphere. So, of course, clear air mode is typically used to detect the smallest objects in the atmosphere, the things that don't reflect much energy, such as light snow. Also, atmospheric discontinuities, meaning that where there is a density difference in the atmosphere, the air density, you can actually get refraction off of that of radar power, radar signal, and you can actually detect sometimes things like that, like fronts. Fronts are regions where you have two air masses that have different temperatures as a result of different densities, and that shows up really well as gust fronts. Typically gust fronts, though, you're already operating in precipitation mode. So the WSR-88D actually has two different types of clear air mode. It's volume coverage pattern 31 and 32. These scan up through 5 elevation angles. They don't go very high, only approximately, I think it was about 4.5 degrees up, so not very high. And it takes a long time. Typically it takes 10 minutes for a complete radar volume in clear air mode because it's scanning very slowly. Conversely, precipitation mode, of course, occurs when there's precipitation. It scans to much higher elevation angles because it's looking for convective elements, in other words, thunderstorms that are perhaps close to the radar, so it has to scan a little bit higher. And, of course, thunderstorms change very quickly, cumulus clouds change, so this scan strategy is very quick. Typically, the PRF is adjusted and the rotation rate is faster, so it can scan entire volume from a half a degree all the way up to 19.5 degrees above the horizon in only 5 minutes. As mentioned earlier, the rotation rate is much faster. The pulse lengths, they're a lot shorter. You don't need to send out as much power because the targets that are out there are reflecting a lot of radar signal. So they're much stronger returns, so you don't need as much power. And they adjust also the PRFs. So there are 7 different VCPs that are used for precipitation mode. If you want more information on each one, you can go out to the National Weather Service, their training center. They have a link at the bottom you can click on, and it'll provide you much more information on their VCPs. And remember that also with volume coverage patterns, the radar does not scan all the way up to vertical. In other words, it's not pointing straight up. In precipitation mode, it only goes to about 19.5 degrees. So if there are thunderstorms close to the radar, then it will not be able to pick out their tops because the radar beam is only scanning perhaps maybe through the middle of the storm. That region where close to the radar, where you have a gap in radar coverage, is called the cone of silence. And of course, it's very close to the radar and down near the ground, but as you go up, it goes out farther from the radar. So that is a little bit about volume coverage patterns for National Weather Service WSR 88D radars.